Hi everyone and welcome back. Welcome to my another video. So I'm creating some miscellaneous videos on the random blog topics which I was writing. Apart from that, I'm currently playing with the playlist on Bootcamp that is covering everything about the web developer bootcamp. And in between that, I'm also publishing these videos which talks only about JavaScript stack and really popular topics. Okay, so in this video we are going to talk about how you can scale your node.js apis which can serve 1 million requests per second. Okay, it might be surprising, but yes, you can do it. The only thing is you just need to know how to do it, right? Because yes, you wrote an api, can it serve the 1 million users per second? I mean, node.js is a known IO blocking and it can serve 1 million requests per second. The only thing is we need to adopt some strategy, adopt a scaling strategy. So that all those things we are going to talk about in this particular video. So we are going to understand how the Node.js API scale. Okay, understanding the Node.js API scaling. And before that, I mean, let's say you build a microservice, Node.js microservice, and you want that your Node.js API should be able to handle the traffic of, let's say, million users, right? So what all things which we need to be worried, which we need to work on before doing that? So that all those things I will try to cover here. So first important part here is your efficient code and architecture design. It's not like I built any random code which is complex, which is not maintainable, which is not scalable, and I wrote some async await promises all and all those things, and I thought like, okay, I can handle lots of requests, because it's all about at the end we are executing your code. Are you breaking down your complexity into chunks? Are you packaging or splitting the code logic in such a way so that it can be reusable and it can be scalable? That all those things really matters when it comes to the scalability. Otherwise, when it comes to getting the job done, you can get it easily. But when it comes to scaling, it all these factors. Okay, what all dependencies are you using? How much? What is the import cost of dependency? Is it executing way too much code to get the job done? Let's say you just wanted to check if a variable is undefined and you just imported a chunk of code which is taking, like, consuming a lot of memory even before executing. So all those things you need to take care. Another important part is decoupling. So whatever the code we are writing, that should be loosely decoupled. Okay, and code optimization is something which we always need to worry about. Okay, because we should be able to write optimized code, because we want 1 million users to handle this. So all these things are at code level. There is nothing we are doing on the infra side. It's all about, okay, whatever you are writing, that should follow the best practices and best standards and should be able to scale properly. Okay, now we'll talk about horizontal scaling, because this is another part, and I can just put it somewhere here. Horizontal scaling and how we can scale. Let's say I'm running my Node.js service on EC2 instance without load balancer. So it's like a one system which may be consuming, let's say, 2 core and 4 GB. So maybe somehow I will be able to manage the 2 PM to, like, I can use the process managers which can split the process, like 2 process consuming individual core. But when it comes to the horizontal scaling, I won't be able to get that much traffic, right? I need to be able to scale it in such a way that, let's say, even if I have 4 systems, because it's all about horizontal scaling where you can put a load balancer in the front. So let's talk about that here. Where you can put a load balancer in front of your system. So this is, let's say, ELB, and here you can have your tiny systems. Okay, I can just say T2 micro. if you are using AWS platform. So this is horizontal scaling, and then you can just use this load balancing algorithm, okay, how the traffic should be diverted using round robin fashion, or using least connection fashion, or using IP hash. But now, earlier, if the same system, if there was only one system connected, it was handling 100 requests or 1000 requests. Now you can handle 3000 requests, because it is still handling only 1000 requests. 1000 other requests are forwarded to this, 1000 other requests are forwarded to this. This kind of a strategy you can also adopt. Let's say I have a big system. I have a T2 medium or T3 large, I don't know the name, which has, let's say, 4 core and 8 GB. It's still a single system, right? It can handle a lot of CPU computations because it has a 4 core, but again, it's a single process. Then you have to use some kind of a process manager, and you need to run multiple Node.js instances on this, which is possible. You can attach a multiple Node.js instance which can run isolatedly, consuming an individual core. It will consume one core, so I think it is a 4 core system, so I can easily run the 4 core 4 processes. So in that case, you don't need to worry about application load balancing, because that is internally being managed by the library like PM2 process manager and all. But this is how you can do. So you can do a load balancer configuration. If you are using load balancer, then you need to worry about, okay, how you are doing a health check, like which instance is healthy. Let's say if it is unhealthy and you are sending the traffic, then obviously you are getting failure. Let's say I have a 10 T2 micro instance and couple of them are unhealthy. So obviously I need to divert the traffic to the rest of the systems. Then session persistence, because persisting the session should be the common platform. Let's say here, this is a session, or persist medium, cache, elastic cache. So that should be common. Otherwise, what will happen is, because the traffic is coming from multiple resources, so every compute machine should be able to check, okay, does the session exist for this user? Because let's say the first request came to this instance and you persisted the session. Obviously, you can't persist the session on the Node.js instance in the memory, because let's say second request is coming to this T2 micro and you don't have a session, and you will say, okay, you are not logged in. So you need to have some kind of persistence mechanism which can store the session, and every instance can go and check, okay, does my session exist? So all those things, load balancing configurations or considerations are different. Like how you do this, we are just using simple application load balancer, and you can use on the cloud also, like AWS provide ALB and auto scale configuration also. So if your systems are scaling, then you can add an auto scale configuration, so it will add instances automatically. You can monitor and fine tune all these scaling configurations, okay, if these many requests are coming, and you can even scale based on the number of requests, number of users, all those things. Now another thing is the caching, because if we are doing caching, that means you can serve more, because it's always that there is a data source. Here you will have MySQL or Postgres database or Aurora DB. Let's say I have a MySQL. So obviously a call to a MySQL database on any instance, let's say, will always cost you, because obviously you need to query the database, and then the database will respond, and then you will send the response back. What if I am storing the partial data, or let's say the request response data temporarily for a particular time in the memory itself? Maybe you can use elastic cache, or because in memory is still a problem when you are using a ELB, because let's say one request is coming here, second is coming there, so you will lost, right? So instead of that, what you can do is you can have an in-memory caching. But in that case, if the request is coming here, then obviously it cannot access its memory, which is stored here. So it also check, okay, in memory exists or not, then otherwise call the database. So better option is you can externalize the caching. instead of in memory. For this particular system T3 large, you can have an in-memory caching. Obviously all the requests will be coming here and you have a common in-memory persistence. You can access that, let's say if you have a single instance, but for multiple instance also that will be the same problem, because there will be a 4 different Node.js processes which cannot share memory. Memory is like a runtime memory which exists till Node.js process runs, right? So you have to externalize the caching to elastic cache like Redis you can use, and Redis is really fast. You can say it's a quick fast memory database. Instead of looking into the database, you can just get it from the Redis. If it is there, it will return directly. And if all these systems are accessing the same Redis instance, same Redis cluster, then it's very easy. It will give you the response in the fraction of seconds, and that's what we want. Client-side caching, if you are just serving the static resources also like the images, HTML, JavaScript files, then client-side caching will disable making another further calls for getting the same resources. Another important part is a database query, because when you want 1 million users, how many users, how many zeros, these many number of users wants to hit your APIs, then you need to improve at each and every level. And what are the levels? First is your code level, that your code should be more than efficient, because I know you can write a code which can take a 5 seconds for the same logic, because if you are not handling the asynchronous JavaScript properly, you are already blocked. Okay, then code, and then scaling your system infra where your Node.js process is running, and then the external system which you are using to store the data, which is database. So this is your application system where your Node.js server is running. So all these factors are important, how they perform. So the next part is the database query optimization. Okay, because we are using database, and we need to know that how we can improve the query optimization, how we can do the database optimization techniques. And when you are using elastic cache, let's talk about the previous topic, which is elastic cache. Then another important aspect is how and when to invalidate the cache. Okay, I have cached the whole API response, which is really a frequent API call, but when to validate it. So there should be invalidation techniques, explicit invalidation about particular time, or key based invalidations, or API based invalidation. Let's say if the update is happening now in the database, we need to invalidate the key. Time already expired 15 minutes, invalidate the key. And because this is mostly key based invalidations, if you are using elastic cache and Redis, you are going to create a key value pair, and inside a key is the elastic cache key and the value is the JSON object or the data. Okay, database query optimization. And everybody knows, like if you are building a database, then obviously we will be putting the proper primary keys, referential constraint, foreign keys, and proper indexing of the columns with which we wanted to fetch. Like let's say I have an email unique, put index over there, create a index based on the query we are fetching. Let's say the employee ID, email, course name, if those are unique, then put a index. So whatever the column using which you are doing a where clause, try to put the index on top of those columns, so that the fetching is a little bit optimized from database side. How database managing the optimization, it's on the database. Another thing is the connection pooling, because we are doing this database, all the requests are going to the database. So it's important how many connections, database connections you can get. Let's say if you are getting 1,000 requests, and at the moment if the 900 requests are busy querying database, so obviously you will be end up creating a 900 connections to the database. So it's better to create a connection pool where you can create n number of connections, and whenever the connection is released, it will put that connection again back in the pool. So whenever the request comes, it will get the connection again and it will query your database. So yeah, there are the ORM provides a connection pool also. Either you can connect to the database directly using connection URL, or you can provide a connection pool configuration, where you can configure, okay, I need at least 100 connections to this database on this instance, or not even 100. Let's say I have 5 T2 micro, so obviously I can have minimum 20 to 30 connection pool connections which can be managed by the connection pool. So whenever the connection is occupied, you don't need to wait for the next connections to be associated, right? You don't need to query for with a new connection, it's already there. Query rewriting and query caching, that's another thing. Query, but because what we are doing in the database is we are querying to the database for the data. So query should be optimized if you are doing some kind of a joins and all. Otherwise, for the basic select statements, you just need to fetch only the right set of data, and you should put a where clause on the unique indexes, or the indexing should already be happened. Okay, so database performance is all about how you manage, how you are doing the indexing of the column, how you are configuring the tuning, and what are the workload. Because database also comes in the variants, like, okay, because database is at the end is a system running on the cloud. It can be a medium instance, large instance, and all. So you need to take care of how many users or how many traffic you are getting. That means I can have a large instance, or always I use for these purpose Dynamo, because Dynamo will auto scale. You don't need to worry about what configuration you did put for the database. Dynamo is a NoSQL, AWS managed, but when it comes to scaling, it auto scale. You don't need to worry about, okay, I should put a T2 micro or a T3 large or medium RDS instance. So that is already being managed. Or you can use MySQL Aurora. Even if you are going to use RDS, you can use, I think, MySQL Aurora, which is AWS managed, and it can scale very well. That I was talking about, this is really important, and it comes to the code. So we talked about database, query optimization, and all. Now first is asynchronous and non-IO blocking code. So what this is related to what you are writing code, because Node.js provides you the good opportunity that you can write a non-IO blocking asynchronous operations, and Node.js internally uses the event loop. So that means when the request is coming, it's not blocking the main thread. Whenever there is a request is going to the database, it says, okay, I'm putting you to the event queue and let other request come in so that I can process it. So Node.js is by nature is single threaded non-IO blocking. So we should harness the power of the Node.js and write a code in such a way that we can utilize the maximum concurrency and throughput by writing the non-IO blocking code using callback, using promises. Because if you write too much async await, you are actually blocking the main thread. So always try to use callback and the promises in such a way that you are not blocking the execution of other requests coming in. The another thing is simplifying the asynchronous flows. Don't do too much async await, just try to simplify your asynchronous execution using promises and the callback. And apart from that, use event driven. So this is the one. Another is event driven architecture, because we are using microservices, and microservices can do whatever you have requested. But when it comes to the processing, then you should always delegate that to the event driven system, where you can throw the event, and then there is some other subscriber or listener is dealing with that event and fulfilling your request, instead of doing everything in just a one single microservice. Let's say I have a couple of microservices for simple order processing. So I have like 1, 2, 3. If I try to do everything in a single request, okay, there is a request of create order, and if you start doing, okay, I have created order, then I will be sending a notification, I will be creating order, and also creating the payment, everything I'm doing, then obviously it's going to take a lot of time, and I'm blocking lots of requests. I cannot scale very well. So my objective is only to create order and through the event order created, and I'm done. I will just acknowledge the API requester. Okay, I'm done. I'm sending you 200 because I have order created. Now this is the event which you will send to the party which is receiving the event. They will take care of creating the order. okay, order is created. Now I will create a payment subscription or something like that, and I will manage that. So these are like loosely coupled systems which can communicate with each other using events. They don't know each other. The only objective of this is to create order and acknowledge. So I can send thousands of the request of create order, because it knows I can create 1,000 order and then send 1,000 events to the listener service. That's fine, because this is totally asynchronous. We are not blocking anything here, and user is not even aware that we are emitting 1,000 events parallelly, and then the listener service is listening to events one by one. This is already asynchronous. We don't need to worry about, okay, what is the load, how much time it will take. It's a background job. So always try to build an event driven architecture in an event driven system when you want to scale the whole system. Node.js is not a multi-threaded, but when you want to create any process, then always create a child process using worker thread. Let's say if you are doing some kind of a computation or bulk processing, then you can use a child processes or a PM2 instances. You can use a process manager like PM2 and create a child processes for that. Okay, you should be able to error handle the asynchronous operations in such a way so that we are not creating a bottlenecks in the execution. Performance considerations, the another important part, because I wrote this blog, so I'm just picking these points one by one. This is performance considerations. So we should always be able to, let's say I'm building an API with a millions request handler, so I should be also testing it. I will be checking the load balancing configurations. Is there any memory leaks I'm performing? Any kind of a blocking event? Am I blocking the event loop or event queue? Because let's say if I'm writing codes in such a way that it is stuck somewhere, like 100 requests together going and they are like not performing well. So if you are using a blocking code, lots of await statement in just a one single block, and in await you are doing further 10 awaits, obviously you are doing a blocking and you cannot perform that well. Another important part is using the microservice architecture approach to build this kind of, let's say I was talking about event driven architecture. Let's say if I need to scale in such a way that I can handle the request of thousands users, then obviously I need to adopt some particular mechanism of event driven architecture or some kind of microservice architecture that can evolve over the time. And then next thing is what approach you are building for building the systems. Okay, because you can use a RESTful services, you can use a GraphQL. At the end, all are like code you are writing and they are responding based on, they are relying on the HTTP protocol. You can also use a gRPC and you can use a proto buffer and all. That's based on your requirement. So you can be using simple RESTful services or a GraphQL services. You can be using simple gRPC interface where you are sending a request using proto buffer and getting the response back from the receiver service. Or if you want to scale it in a different asynchronous way, you can use the message broker, because it's all background processing. I will just receive millions of requests and I will delegate it to the background process. That's another way of getting the millions requests, but in that way I will be just acknowledging the user that I will process your request. I won't be sending the response right away, because it's all asynchronous operations where you are using RabbitMQ, Kafka, SNS, SQS. Whenever you need a background processing, you use these asynchronous mechanism, and obviously they scale very well because you are not doing something right away. You are actually batching the request and performing in the background. Then performance monitoring tool, maximizing the efficiency. You should identify the bottlenecks. Okay, what are the bottlenecks in your code performance? You should try to identify it and try to evaluate and try to remove it. Performance tuning, and so there are lots of performance tools like, okay, I know New Relic, Key Matrix. New Relic gives you really nice overview. Okay, how much CPU you are consuming, what are the request per I have used New Relic and I was like sending the thousands of the requests using these node tools to do the performance monitoring. and you can get even the statics of individual API, that this API is responding in 6 millisecond, 100 millisecond, 1000 millisecond. So you can use these tools to evaluate. Okay, do I need to improve at the code level, or do I need to improve at the infra level? How many request queries are going to the database, because it can evaluate your database, it can monitor your EC2 instance, it can monitor your Lambda, anything. That's a New Relic. So because you need to take care of the response time, you need to reduce the response time, you need to increase the throughput, you need to also monitor the error rates coming from the APIs. Let's say after I send 5,000 requests together, I started getting 404 or gateway timeout, because nobody was able to handle that request. So all those things you should be able to monitor through these monitoring tool. You cannot build your own monitor tool. You can utilize all these tools. You need to monitor all the error rates for 4xx, 400, 401, 403, all these requests. Let's say if you are hitting 1,000 requests together and you are not able to get the elastic instance, and it will just start throwing you not found, not found. So you know, okay, what is the latency and how much you are utilizing the CPU resources, because this matters. Okay, if you are using 8 core instance or 4 core instance and your CPU utilization is only 10%, that means you are not doing something right. You need to improve it. Either divide your resources in such a way that you can utilize the resources properly instead of just spinning up the 10 more instances. Performance testing and load testing. Obviously load testing is really important when you want to serve millions of requests, and there are lots of modules which can actually create threads like JMeter. You can use that, will give you the real user feeling. You can create multiple threads and they can act as the individual users and start sending the request to this. Other than that, all the other aspects of improving the APIs, increasing the securities and all are in the considerations. You should be using rate limiting, but those are all API security aspects. But other than that is, you should be using compression at the API level, compress data. You should be using HTTP 2, that is faster than HTTP 1.x. You should be using CDN integration. If you are using some kind of a static resources, then you should be using CDN to serve those content. Compression, use some kind of a gzip library that can compress the content being served from HTTP interface. Okay, these are some of the consideration. I mean, this is really very big topic. There is no such thing like, okay, this can be done. You should be using secured mechanism. Obviously, you should be using HTTPS and TSL. You should be using a proper certificate for your domain, and you should be using, then it comes to all security aspects. You using the role-based authentication authorization. For security, you should be using all security aspects. For the APIs, in that case, you should be using rate limiter. Right? It's not like, okay, you are not using a rate limiter and somebody is spamming the request and sending the million requests. Okay, so in that case, rate limiter and handling these all HTTP headers. So you should be using Helmet and all secure and security added modules, NPM module for your APIs. You should be using a proper logging, security, all the 10 different aspects of building a robust production ready application. All those things will be coming into the picture. You should be taking care of the SQL injection, penetration testing, vulnerability and all. Okay, that's all. I will be also sharing a link of my blog which talks about all those things in more depth. Okay, I hope you will just look into that and get more understanding about how you can write a Node.js microservice which can handle millions of requests. Yes, Node.js can handle it, but with the right configurations and right setup.